and welcome to the webinar, everyone. Today we will see the popular data ingestion tool and visualization tool associated with Elastic Stack. Let's see what's the agenda. We'll briefly go over to the ingestion story that Elastic Stack has, and then we'll also go over the see what the Logstash or the popular ingestion module with Elasticsearch used for. Is it only for logs, as the name says, or what are the various features that are available with Logstash? And also we'll go ahead and see what are the configuring parameters, or how do you manage Logstash, how do you scale Logstash. And finally, we will come back to the visualization of data using Kibana and various visualizations associated with the data that is ingested using Logstash. We will see a bit of demo or use cases that you could do with Logstash along with the various topics that we have discussed. So this is Elastic Stack, the open source version. The current latest release of this Elastic Stack is around 6.3 and not 6.2. There is no enterprise version for this entire stack. Elasticsearch is the heart and soul of the entire stack. You have Kibana on top of it, which helps you to see what is happening with your data in this module, and also it serves as a window to the stack. But the most important part of the Elasticsearch is data, because it's a search engine. It needs data to do visualization or analytics or even search, right? So Beats and Logstash are the modules which help you to do such ingestion. So Beats and Logstash form the ingest story in Elastic Stack, right? We also have XPack, which is a commercial offering. So XPack contains features, or it adds additional capabilities like monitoring, reporting, security, and machine learning. It also has recently it got introduced with something called SQL. And there are some hidden features that you might not be aware of XPack, which we would see briefly today with regard to the Logstash and the data ingestion. Now, with the combination of XPack and Elasticsearch or the Elastic Stack, these are the various use cases that you could use today with the entire stack itself. So it could be security analytics, log analytics, metric analytics, or it could be anything, right? Or recently the application performance monitoring. All of these need data, right? All of these need to be available, or need to be done only when you have huge amounts of data, and you need to ingest the data into the Elasticsearch using some or the other. So that is when Logstash comes in. So we have discussed about it in the first webinar as well. Logstash has wide variety of features. It could be like, it could ingest data of all shapes, sizes, and sources. It has a huge plugin ecosystem. We will see briefly about some of the plugins today as well. It also allows you to build pipelines to pull data from various sources, and also push it to various other outputs, right? It could also be used as a generic ETL tool like extract, transform, and load as well. So this is the regular architecture, or the popular architectural model that people use with Elasticsearch or Elastic Stack, right? So mainly, if you see, right, Logstash is central part to everything that you do. So it could be Beats that is talking to Logstash and do some transformations or do some data enrichment and pushing to Elasticsearch. It could be any other data store like RDBMS system, which pushes data to some message queue, and then it comes to Logstash, and then it pushed to Elasticsearch. So all of these possible, like all of these are very much important, and Logstash plays a vital role in all of these use cases. So some of the popular data source associated with Logstash is, right, Beats is one of the inputs that Logstash supports by default, and you can use various beats like metric beat or file beat. There are several beats today which could pull data to Logstash, and then it could push to Elasticsearch. So Logstash will do transformation or enrichment, as I say again and again. So this will help you to enrich the data in a format that you want to do search or analytics. But there are several other sources, like suppose you take a Salesforce or a streaming data like Twitter or any other web app, right? It could be also something like a message queue or anything related to open source which has an API, right? So Logstash can pull data from all of these sources and also enrich the data. So there are huge, I mean, there are so many input plugins available with Logstash, which helps you to do this thing. Not just pulling the data from various sources, Logstash also pull data from RDBMS system, and also it can do pull data from IoT based systems. So these are various other areas where Logstash can also interact with. When it comes to pushing data, or when it comes to output this data to various sources, Logstash can be used for doing all of this. Like suppose it can definitely write to Elasticsearch, but it can also write to any archival or any cloud storage systems, right? It can also write data to in a specific format or in a specific index mentioned by you. So Logstash is used for very wide varieties of use cases. But how it works, right? Logstash works for this particular, it works in a similar this manner. Suppose if you see here, right, so this is a typical pipeline mechanism. We will definitely understand what a pipeline is, but if you see here, there is a set of input plugins, there's a queue in between, and there is a filter plugin. So input plugins basically nothing but the plugins which interact with external systems, which pull in data, or which receive or listen on a port to pull in data, to take the data. And there could be, or if you can forget about the queue for the time being, there is a filter plugin. This can also be a couple or more than of filter plugins, which enables you to transform the data. Suppose if you take a date format, it could transform the date format in a format that you want it to be, rather than the format that is in the database, right? It could be structured or well made into a format that the user wants. So again, it can pull in the data to several other plugins as well. So but why are there multiple pipelines? We'll definitely see it, what is a pipeline and how it works. But how do you configure this Logstash? I've been talking all the time about input, filter, and output, or pulling the data, right? This is how a typical Logstash configuration file will look like. Suppose if you could think about input, filter, and output is the standard structure that you need to use in a Logstash configuration file, wherein input will contain the input plugins, filter will contain the filter plugins, output will contain the output plugins. So Logstash will work with all of these plugins together and pull in data, transform it, and output it to a system that you want. It could be standard out, it could be Elasticsearch, it could be any other cloud storage system. Suppose you take a typical use case of Logstash is a log and ingesting log lines, right? Ingesting log files. So this is a typical Apache log where you have client IP here, timestamp here, and you also have a HTTP verb and a HTTP protocol with a version and the response code, and also the request to the resource and the user agent from which the user has requested this particular resource. So when you pass this, what you want to do is like convert this in a manner so that you could run analytics or dashboards on top of this, right? Suppose you want to make sure that how many response codes are like 200. Am I delivering more 200s or am I delivering more 400s? All of this can be analyzed using Kibana, but you need to first structure this data in a format that you want. So what helps here? So if you see here, right? So if you configure Logstash here, the input is taken from as STDN, and there are some filter plugins, and there is something called output. Let us go and understand more deeper about what is this particular structure speaks about. So if you see here, right, STDN is nothing but standard input. So the log line which I presented, I can give it at the command line, and it just passes over the filter, right? If you see the filter here, the Grog is a particular plugin that works with Logstash. What it does is it simply breaks or passes that log line into a separate JSON on a structured manner, or a separate JSON file. So also you could see the date plugin, which converts the date into a specific format. So this is what the filter does. Filters people use, or developers, Elasticsearch developers use various filter plugins, right? Custom filter plugins to match or change their data in a format that they want. But most importantly, when you change this data, you should be able to push the data to Elasticsearch, right? So there is an Elasticsearch output plugin, which is used to push the data from the particular source on like the filter plugin to the local host or or whatever the Elasticsearch IP that you have or the instance that you have, you can write it to there. As well as there is no bar to use only one output. You can write it to multiple outputs. That is why I was saying when I was talking about the input and output, it could write to multiple sources, read from multiple sources. So now if you see the particular log line which we discussed previously here, so the log line now resembles in a JSON format. After passing through that configuration file, it will resemble like this. And all of this is done with a log stash, right? The configuration that you have given. So I spoke about Grog. How this Grog works, or what is a specific structure or various words that are used in Grog. You can think of Grog is like like good regex, or a easy way to write a regex pattern. So if you have a log line and you have some sort of a format and you want to pass it and put it into a particular structure of file, then Grog can be your friend, right? You can write various like brackets and use these verbs which are given in the documentation and take your use case or get the thing done. So all of these which I discuss or which I mention here is available in this particular link. You can go ahead and read more about Grog and all the filters that are there, right? But there are some best practices that we recommend for Grog when it comes to parsing the log lines, because parsing could be a costly affair if you don't handle it properly, right? Yes, Grog may not perform well when a match fails, right? So when a match is being done, whenever you try to pass a log file, Grok will tokenize it and make it convert it into several other tokens. So at that point of time, when the importance of match will play a role in the performance. So if it occurs at the first point, it is different. If it occurs at the end of the log line, it has a different sort of performance impact, because you have already spent analyzing or parsing the entire log line already. So for monitoring this match failures, you have something called Grok parse failures, which can be monitored and which can use to benchmark what are the various log lines, what are the log lines that are failing to do this Grok parse. So you can also like use anchors and use some sort of a special characters to remove ambiguity and help the regex engine. But usage of all of these also like is not important. I mean, like will not give you right performance. So when in doubt, when you have the problem, you please use our monitoring for like monitoring plugin of Xpack, like which is free, or you could also use our monitoring API or metrics API, which is there with Elasticsearch, and you can get, or which is there with Logstash and Elasticsearch. You can get more details, all of these. But we have a separate blog post about Grok, the best practices, what you should do, what you should not do, the do's and don'ts, and what are the best practices. You could go ahead and read. I would definitely publish that with this slide deck. So there is a Grok debugger as well, which comes with the dev tools. So today, if you download the distribution, you could see in the dev tools along with console, the Sense plugin, which is previously called as Sense. You could also see this Grok debugger. So you could test your Grok plugin like regex testing. You could do this. You could write a log, put a log line, and create a pattern, create a Grok pattern, and simulate how your log line or the JSON file or the document would look like. So pipelines, right? I spoke about pipelines previously when I'm talking about how Logstash works. So there are pipelines is a concept where you could run multiple configurations of Logstash. So when I say about multiple configurations, it is nothing but pulling data from multiple places. So pipelines enable or aid you to do such work. So basically, if you see here, you could configure the pipelines in a file by mentioning various parameters, and you can increase it iteratively. So please don't jump onto the final version or like do entire stuff at that one point, but iteratively configure your pipeline in such a manner so that it will yield you the end result easily. So you could, there is a feature that we introduced recent times that in pipelines could also communicate with each other. So this is a feature which is in beta. So please don't try it in our production systems, but you could also go ahead and verify how it would work. If you want a pipeline to work on a particular data type, and then you want it to pass to other pipeline, you could do that. So how this particular pipeline work, how does the configuration really look like? So pipelines configurations are present in a file called pipeline.yaml in Logstash. So if you give a pipeline configuration, and if you run Logstash without any parameters, without specifying any specific config file, pipelines would be used. The pipelines.yaml would be used like a base configuration file. Otherwise, it would take in the file. Suppose if you give you a special configuration file, then that would be taken as a basis. So if you see here, right, the pipeline configuration file is defined like a pipeline ID with the name of the pipeline and the config file where it is located, and there is some other details regarding queues and workers, right? So workers are nothing but how many threads or something it would work on the particular configuration, on the particular configuration that you're going to supply. And queue type is a type of queue that we have in Logstash, which enable you to work with the data that is there. So we will definitely look into various queues that are there in the coming slides as well. So this is a centralized pipeline management, because tool that we have with XPath. Why we have introduced this in the particular offering, because it could be difficult after some time to visualize the pipelines in a command line or in a configuration file. So pipeline management is part of the XPath. You could go ahead and see that and visualize the pipelines which are there in the offering that we have, and understand what is happening in your infrastructure. This is one more interesting feature that is available with Logstash. So Logstash has something called modules. So Logstash modules work in a different manner, that unlike the regular configuration files. So Logstash helps you to set up things. When you use a Logstash module, it helps you to set up things automatically. So if you enable a particular module, there are 3 or 4 modules today. So if you set up that module, it would create the index, it would run the pipeline automatically, and it would also set up the dashboards as well. So today there are 3 Logstash modules that are available for you to use. They are Elastic Cloud, ArcSight, and NetFlow. So Elastic Cloud is a cloud offering from our side, where you could integrate the existing infrastructure of Elastic Cloud Logstash with Elastic Cloud, and you would get all sorts of data into Elasticsearch as well. The other interesting modules that we have is ArcSight. ArcSight is a popular SIEM tool, security information and eventing management tool, where security data is published onto it. We have integrations with ArcSight, which would look like this. Suppose you have ArcSight smart connectors, which are like agents which publish the data in a common event format to Logstash, and which would be further used to set up dashboards. Similarly, NetFlow collects the network data in any organization. So when you integrate all of these modules, right, or some of these modules, it could look, a dashboard generated by this automatically would look like this, right? It would generate the heat maps. It would show you the place where the requests are getting originated, or the various IP ranges that are being coming to your web app. So coming to the topic of data resiliency, we spoke about the configuring, or we spoke about how you would construct these configurations, how would you run these pipelines and all. So but data, right, when it reaches out of some scale, you need to have resiliency. You need to contain it in a manner so that you would persist it and then work on the data that you have sometimes. So Logstash it comes with 2 queues. One is called persistent queue, and other one is called the dead letter queue. So persistent queues are nothing but handle the burst of events. It pools or spools the requests or events that are coming to the Logstash onto your disk if you enable it, and handles the bursts of events that are coming to Logstash. So literally it serves as a queue and handles you when in case of any event or restart of a machine, then it would enable you to do at least once delivery to Logstash pipeline, so that your data will always be run through pipeline at least once. Data loss is handled in this particular queue. So persistent queue is most widely used. We have introduced recently, but it's been enabled in several architectures. Even we recommend it doing that way. So dead letter queue is another queue wherein you have a specific pipeline configured for dead events. So what are these dead events? Suppose if you have a particular event or a particular record of event like a log line which doesn't fit in the filter that you have, the parse will fail or the event will be left out, right? So you could write all these dead events into a log called dead letter queue, which writes into a file. You could run a separate pipeline by yourself in later point of time and find out what are the errors or what are the discrepancies that are there in data, why it is not passed, and you could improve your existing filter or existing main pipeline. And you could also clean these events and again push it through the DLQ input pipeline and then push it to Elasticsearch. So it is a second line parallel pipeline for you to run if you have any events like that. So dead letter queue is also an interesting feature for you to try because it helps you to do error handling kind of scenario. So one of the popular requests or use case is like, how do you scale Logstash? Yeah, I got all of these, right? But how do you find out scaling the Logstash? So whatever I suggest is first you need to monitor or you need to understand what is happening in your infrastructure, or you need to find out what is the scale or what sort of statistics that my particular instance or will talk. Then only you will be able to decide on top of what you need to, how you need to scale, or is there any change that my pipeline configuration should be changed, or all of this could be done when you monitor this. So we have a monitoring plugin which helps you to do this monitoring. It would show you all of these charts which helps you to find out the latencies, event receive date, or even JVM heap, or even like CPU utilization, everything it would all do. We have an experimental feature to see pipelines as well. You would be able to see the pipeline and events emitted rate and number of nodes that are working on this particular pipeline as well. Excuse me. But in the event of anything, right, always you have to do this, right? Measure every time. Measure the infrastructure and measure the particular load on your server. Then only try thinking of scaling or adding another Logstash. So you need to always find out the load and various other parameters when you are thinking of scaling Logstash, and you're thinking of finding out what are the bottlenecks that are associated. So this is a nice plugin to look at. It comes with the default distribution today. So when you scale Logstash, so what is the architecture that we recommend? What is the architecture that we suggest to you? So these are one of the popular architecture pattern that we recommend when you have Logstash, which has several plugins like extract fields, geoenrich, lookup enrich. All these are several filter plugins that are there with Logstash. So you could use directly one of these beats to push this data, or also you could use a load balancer in between, which talks to a HTTP port and on the Logstash and then convert. But all of this with a caveat: persistent queues. So Logstash itself is a server and it will be able to handle a good amount of requests. But in case you have more events that are coming in, you could use a Kafka in between, which acts as a message queue layer and which will enable you to parse or transform or buffer all these events, right, using Kafka. So I spoke about all of these, right? So what are these plugins? Every time when I say plugins, right, Logstash is a huge plugin ecosystem. So there are several plugins that are there with Logstash today. So it could be input plugin, output plugin, and also filter plugin. So when I say input and output plugin, it could be like something like a Redis server, or it could be like a RDBMS system. Same with output plugins. Those are plugins that are available in the wild. Input and output are quite common. But filter is quite interesting, right? You want to know what sort of filters, data transformations or enrichments that you could do with filters today. So parse or extract filters are one sort of filters that you could apply with Logstash. So we have seen the Grog filter today. So which we mentioned. I have spoken about this line which we have seen previously. It just converts the log lines into a specific format that you want to do. It has also something like pass and date is also another pass and extract filter, where it could convert the date into a specific format as well. This is an interesting filter. Suppose you have to pass the data into key value pairs, right? So using a delimiter, so you could use KB filter, which helps you to pass this particular data that is present. Similarly, you have core operations filter, which helps you to do some specific core operations. Mute filter is one such popular filter that is available, which helps you to manipulate the fields in the logstash. It could be converting the field types from something like strings to into integers. It could be like something renaming or replacing the particular fields. It could also be like merging some particular fields or split fields into arrays and removing white spaces. So all is possible with these mutate filter. Mutate filter is one of the popular core operations filter which works on data enrichment part. So these are core transformation filters that are used today. Similarly, you have, I spoke about make. Similarly, you have split and drop. So split will divide, as the name says, divide the single event to multiple events and run through. It could also be sourced through several other pipelines as well. Similarly, drop event is a traditional when you don't want a particular event to be passed on a condition, right? You could do a conditional if check and then remove or drop an event that you don't want to be passed. So all of this can be possible in the filters. So it's a typical example of mutate with if a conditional, right? This is a typical example with mutate, split and drop. So if you see here, if the account is lowercase, like you are trying to lowercase a particular field which contains the data, and also then you are trying out if the type is a batch, then you are trying to split that particular field into separate actions and all of these. So these are traditional or the filters that most used filters in the core operations or the data enrichment part. Similarly, you have a search supportive filters which enables you enrich data so that you could search on the data that you are passing through Logstash. So geo IP filter is one such popular filter which helps you enrich the IP address. Suppose you have an IP address which if you pass through this filter, it would convert you into a geo hash and place it so that you could place this particular geo hash into a regional map so that you could see heat map, which we have seen a few slides before in the NetFlow module, so you could see where the requests are coming from. Similarly, you have a user agent filter, seen this as well. So if you see a user agent will find out the kind of agent or the browser that the user is using, the user is requesting the data from. Translate filter is one such other filter which helps you to enrich the data as well or convert the data into a dictionary and make it more usable in search. So this is one of the other popular filter that we have with Elasticsearch. So Elasticsearch also, there's an Elasticsearch filter as well. If I have to tell, Elasticsearch input plugin is there, Elasticsearch output plugin is there, Elasticsearch filter is there as well. So you could run a query on top of Elasticsearch and then also convert the data and again push it to output. So all of these possible with filter plugins. So this is one such popular and important plugin that I have kept it till end because we would discuss a bit more on what sort of filter that is there here. So if you see here, right, there is a particular JDBC configuration that I have written. What is this? What this talks about? So when we spoke about Logstash in the first slide, I said that Logstash talks to SQL server and then it pulls in data from SQL systems, right? So talking to SQL is possible by one or more ways. So JDBC is one such popular way to talk to RDBMS systems. So JDBC means Java Database Connectivity. So you have these jars available for each of these RDBMS systems. All popular vendors publish these jars, which contains the Java class, through which you could talk to the SQL server and run queries and get data. So similarly, we have a JDBC input plugin, which if you enable and you could give you this configuration, today we will see this particular example, then you would be able to find out the data that is present in the SQL table and sync it to Elasticsearch. Thereby, you could add a search experience to your Java app. So here, if you see, you are just giving a username, password, and you're typing a particular statement, and then you are passing some parameters so that like you are converting or pulling the data from this particular field, and then you are filtering this data. So then you can push this data to several other places as well. So there is a JDBC input plugin, JDBC streaming filter as well, which would do the same work. And these enable you to add search experience to Elasticsearch. Now let's go ahead and see some demo on this particular example. So I have in my DigitalOcean environment, I have an Elasticsearch node. I have a Kibana node, and I also have a Logstash node. Each of these does the same work that, as the name says, Elasticsearch runs Elasticsearch service, Kibana and MySQL. MySQL server runs a MySQL server, and then it contains some data. Let us see first of all the MySQL server, what data that it contains. So I have created a database schema and a table to find out to pull data from this particular RDBMS system. I have a table called authors, which has a huge amount of data. I have 1,000 rows in this particular table. All of this is dummy data. If you want to see the count, we could run the count query as well. So if you see, there's rows in this particular table, right? The idea is to pulling this data to Elasticsearch, and thereby you could do analytics, or you could do interact using some of the other regular REST APIs to do some search using this Elasticsearch, right? So let's go ahead and see how do you add the search experience. So I have Elasticsearch search service running on one node, which I have shown you. I also have Kibana running. I have a Logstash system, and I also have a MySQL server. So these are the 4 nodes that we have seen. So our point of interest is Logstash at this point. So in Logstash, what I have done is I have downloaded a MySQL jar into the bin folder, and I have created a config script, which I'm going to show now, and then I have run the configuration so that it pulls the data from the particular source. Now let us connect to the server. Let us go to the Logstash instance. Because I have installed a Debian, it goes into a particular folder. So if you see, I have a MySQL connector directory. I will go into the MySQL connector directory. So I have a MySQL jar. I also have a Logstash JDBC conf, what it says, right? Let's go ahead and see what this JDBC conf says, right? It is written in the same format that I was mentioning previously. If you see here, it has the input which says JDBC, it has a driver library, driver class, and all of these, right? It has a statement which says select star from others. That means it is pulling all of the data. And it is also saying that it has an output which pushes to Elasticsearch, and it has an index named authors, and the hosts are the IP address. I've just given the IP address that where Elasticsearch is residing. So let us go ahead and run this pipeline. So the Logstash is there in one directory up. So I just gave that command, and when you want to run a particular config script, so you have to mention it with -f. This will override the existing configuration, and this will help you to run the your own configuration. Otherwise, if you run the existing simple Logstash, it would take the pipeline as the pipelines.yaml as the default file. That means it will start running whatever it's there in the pipeline. It takes a bit of time to initialize the pipeline and start working on the configuration that we have provided, and it will simply pull all the data and write it to the Elasticsearch. If you see that it has pulled data from okay, if you see that it has pulled data from the authors table, and it has terminated the pipeline. Now let's go to the Kibana and see whether this data is visible or not. This is Kibana that I'm using on this particular connected to that particular Elasticsearch instance. So I have already configured a authors index pattern. So if you want to if you want to put data into Elasticsearch, you have an index, and then you need to configure the index pattern here so that the data is visible in the Kibana. So the other way that you could search what are the index that are available with Elasticsearch, you can come to the DevTools API here and then go ahead and give this cat indices, wherein you could find what are the various indexes that are available. So all the indexes that are starting with dot are the system indices, and all the indexes which start with a particular name is others. So now if you could see that there are 1,000 documents, I can even show you the web post output. You could see that there are 1,000 documents in the authors index file. We could also go ahead and see what is this particular data, right? You could go ahead and see this. This is a particular record that is present in my RDBMS system, and this is the data time that it got ingested. I could also run a query here to find out a particular records around. So there are 2 colds. My data set is very small, 1,000 records. So it has 2 colds in this particular data set that I have ingested. You could also use various visualizations that are available in the visualization tab here. So if you expand, you could see the names associated with it, and you could run this visualization. Suppose one of the popular visualization that is available with Elasticsearch Kibana is pie data chart, right? You could use pie data chart, and you could use the index pattern to put all the index that you have, or if you have a saved search, right? You could also use that search and save the search and use that search as an input to the visualization as well. So this is a complete authors data set that I have ingested, and now I can also bucketize this data. I can also find various information that is present in this particular data. What are the various information that I could find? So when you split this data into slices, right, you could go ahead and find out all of these aggregations, right? Aggregations is a math concept associated with Elasticsearch. It is something like group by, but if you want to learn, there's more to learn on aggregations. You can go ahead and look at the documentation as well. Today we'll look terms. So terms are specific fields where you want a particular bucketization or grouping to be happen. So I'll select that birth date as one of the term, and I'll run this particular data set, and then I could find and see when each of these. So as I said, my data set is pretty small, so I have people born in all of these areas, right? So you could visualize this. Similar way, you could do more and more bucketizations and more details on what you could achieve with the same visualization. But one interesting aspect that I want to show at this point of time is whether this visualization, what this visualization will do internally. So this visualization will do nothing. If you click arrow here, if you see, it simply runs a query on Elasticsearch as well. So it is nothing but Kibana also runs the queries or interacts with Elasticsearch APIs to do the work. So if you see, you can see the complete query that's being run to get this result. It also shows you that a status takes how much time the query has run as well. So now that we have ingested data from SQLDB, we will see one more demo on top of logs, right? Logs are popular use case with Elasticsearch, right? So people want to use Elasticsearch to ingest logs. So let us go at, I have a logs. So I have a log file here, and which I could show you, and I will ingest that log files into Elasticsearch using the log/configuration configuration file. Once the server connects, we will definitely see that. Yes. User share log/. So if you could see, I have a configuration file called apache.conf. Let us briefly see what this apache.conf has before running. So this apache.conf says that something called beats, and it's saying port 5044, and also has a filter structure which says Grog and GOP. I think we have seen this and we discussed about the Grog and GOP. And you also see that there is an output which says std out and Elasticsearch. That means I'm printing to standard out as well as the pushing to Elasticsearch. I didn't mention the index though. It just creates an index automatically with the date format with the particular logstash host name or the logstash name. So let us go ahead and also run this particular configuration file. So okay, we didn't talk about the beats. So beats is nothing but a plugin in the input plugin, which is the popular input source for the logstash. So when you call this beats, so it will accept the data on this port from any of the beat framework. So beats is nothing but a lightweight data shipper. We would discuss more about beats in the next webinar, but for this time, just think of which pushes the data from a source to a logstash file. So this is the pipeline that you are running with logstash at this point. I have logstash and apache.conf. So I'll just run this logstash configuration file so that it runs. Meanwhile, we could also go ahead and see what is there from the place where the logs are stored, right? I have a logstash tutorial log, which we would use today for pushing. We'll use this as a source or log file to push it to Elasticsearch. We also have a file beat, which pushes the data, pushes this log file to the Elasticsearch. Let's go ahead and see what is there, what's happening with logstash. So if you could see that the pipeline successfully initialized and it has started. There are no errors at any point. It is listening on the particular 5044 port. See, starting input listener, if you could see that. Now let's come here, get to the file beats folder and see the file beats YAML file. So this serves file beat YAML file is a configuration file for the file beat to push data from your source to the destination. So it is nothing but pushing data. You're just giving a destination IP to put to take what and push where. So something like that. So you see type is log, it's enabled, and the log line where it is present. And I have also given the logstash output. I have configured the output as logstash, and I will show you how the details are configured here. If you could see that there is a logstash output that I have configured on the host, and it is mentioning that particular IP address and the port that we have opened it to communicate. Right now, let us run this file beat and push this data. Okay. So when I start running this, it will simply pull this data and push data to logstash. Logstash is already listening here, and you could see what is coming in here, right? Because we are printing it on std out as well. So you could see that the loading of configuration started, and harvester for this file has started. If you see that there's a file that has been started on a particular log line, and it has picked this path and pushed it. Now the file has been pushed already. So you could also see the file pushed here, passed, and also ingested into Elasticsearch. Let's go to Kibana and see how this particular log file has been pushed to Elasticsearch. Right? This is a visualization that we previously created. Let's go back to discover what is there. Now, just like the previous way, I have configured the other index parameter here. Index pattern here. Now go ahead and see. Let's go ahead and see the logstash index that is there. Because it is having a different time period, it might not show. Let's go ahead and see the index here first of all. So the log that I have has 100 records. The index got created. It has a particular time period. So let's go ahead and change the time period to give the request that we want. Okay. So if you could see this one, right? I just zoomed it. So the log lines that we have ingested has been passed like this, and it has been identified, and geo IPs and all the hashes, longitude, latitude, everything has been done by Logstash simply. It just iterated and started this pipeline and ingested the log into Elasticsearch. Now, when you have this, what you could do with the data that is ingested, you could simply put this data onto a regional map that I was been talking about. So let's go to the visualization and start creating a coordinate map. Let me reduce the font size. Let us take Logstash as a source and take geo coordinates as the map that we want to do, and select the aggregation called geohash, and also select the location. So it automatically finds out what is the appropriate field. If you have multiple fields, it shows that, and press the play, right? It simply puts the data onto a map that you have. So you will be able to find out what is happening at which point. So you see a lot of requests coming in from Moscow, then a lot of requests coming from Paris, and a bit from Romania, a bit from Belgium. All of this can be possible. So this is another use case with the logs that you could do with Logstash. And many people use Logstash for transforming the log data or operational logs that they have. They just using Logstash to Elasticsearch. It's a popular use case, and that's how it's called ELK, right? Now we'll go and try to use a streaming data source and find out how Logstash will perform on a streaming data source, and how it would ingest, what sort of real-time analytics that you could do on a streaming data source. So I in the same Logstash file, I have another configuration. I can show that. Could see it is called twitter.conf. So let us go ahead and see what twitter.conf has. So it is nothing but a plugin again. So Logstash has a Twitter input plugin which pulls in tweets from Twitter and ingests into Elasticsearch. Nothing more than that. But you have something called template. What is a template? Let's go ahead and look at the template. So I also have at the same place a template file in the same location, Twitter. So it's a JSON file, it's not a conf file. So what it mentions is, it tells you about what are the mappings, how you want to understand this data, tweet data that you have, what is the type of this data, and what are the various things that you could do, and like what is the user type. These all have implications on the search and queries that you do. So it's essential to keep this data type in data type or index template, and ingest this data accordingly into the Elasticsearch. Now let us run this pipeline with Twitter. What it does is, it talks to a app which I have created on Twitter, and you could create this app as well. You could go to apps.twitter.com and then create an app for yourself and use this. I would show you how I have done that. I will show you a GitHub repo as well right now. But let us first of all ingest the tweets and put it on a index that is there in the Elasticsearch, and visualize the data that is coming from Twitter in the Kibana. Let us run Logstash. So what it does is, it just simply pulls the tweets and pushes it to the Kibana. So once it is started, we can go ahead and see the dashboard that I have built already. So meanwhile, while it starts, let us go ahead and see what I have done with dashboards. So in the management, there's a way that you could import dashboards from another place to another Kibana. Suppose you have developed dashboards and you want to make use of it. You can do that. You can export configuration from another dashboard configuration which you have created in your development environment, and you could import into a instance which is there in production. So all of I'm talking today have been pulled from examples repo. It is open for all. You can go ahead and see here. There are several examples that we maintain here. So you could go into common data formats and Twitter. The configuration files that I have done is taken from here. You can just follow these details, and then you would be able to see all of this in your local system as well. Now let's go to Kibana. I could see the tweets that are being pulled in. You could see the dots represent the tweets. I missed a special parameter that I have to talk about. That is the configuration of the particular tweets. So when I say tweets, it doesn't pull everything, right? There needs to be some way that it needs to pull tweets. So suppose if you see here, there are several keywords that are marked here, which would say which tweets to pull, right? So these are keywords that that the plugin searches and finds out and pulls data from. So I have given ML and data in my configure script, so it is pulling data set or the tweets related to ML. So I have already configured the dashboard. I just need to go ahead to dashboard and click on the sample Twitter dashboard. So it shows me the tweets that are there today. And so right now, just at this point, there are several tweets that have been done. So you could also see what are the top 10 hashtags. You could also see the count of tweets that are happening. If I enable the auto refresh, it would also does automatic refresh and refresh every 5 seconds and finds out tweets happening for every 5 seconds or so. And then you would also see the dashboard refreshing, and you could see the top 10 hashtags that has been built, and the top 10 influencers that are there. I mean, how many tweets have been retweeted and all of this. So these are the various scenarios that you could do with Logstash today.